Well, if you've already watched the video that introduces vector addition, you notice that we stopped off at the point where you may have had vector A being a component like that, and vector B being a component like so. Although much of what we live in and do on a daily basis is based on right angles, that's certainly not reality. We know that, for instance, if we're going to walk down the hallway, we might walk like this, and then we might walk like this, and then we might do this. Maybe that's the path that you take to drive home. But the reality is that the angles between these vectors are far greater or far less than 90 degrees. And this is the basis for something that's called vector addition by components. There are other terms for it, but nobody seems to really agree. So I'm going to tell you that I think it's by components. And here's the general idea. The idea is that if you take a Cartesian coordinate plane, I'm just going to draw a tiny little one where we know that this direction is, say, positive x, or we could even call that east. Let's say you walk like this. We're going to call this angle here theta. Actually, I'm going to get rid of a little bit of this stuff so I have some room. But if you notice, angle theta is between what we're calling the easterly direction and the vector that you've actually taken. And as you actually walk that way, you'll notice that you've also gone some distance along the x-axis. So this is the point of, if you are driving, say, northeast, you are going east while you are also going north. So let's just kind of break this down a little bit. If vector A is right there, then we can call this vector A's x component. And we can call this vector A's y component. These are based on your standard trig functions. So let's, for instance, give vector A a magnitude of 5.0 kilometers. If we are looking to get AX, well, AX happens to be the adjacent side to angle theta. So A, we have the magnitude of, it's the hypothesis of this little right triangle formed here by our components. So we have AX being the adjacent side, A being the hypothesis. Adjacent hypothesis are related to the trig function of cosine theta equaling the adjacent side, which is AX, over the hypotenuse, which is A. That means if we are actually looking for AX, I guess these should have been big old, what do you call that? Should have been a colon, I apologize. So AX will end up equaling A, vector A, multiplied by the cosine of theta. So in this case, it's 5 multiplied by the cosine of whatever we call theta, and just for kicks, let's call theta 30 degrees. This means that our component AX is in fact equal to 4.3 kilometers. It means as we walked vector A, we've gone east 4.3 kilometers. Now, AY is exactly the same process, but it's a different trig function because it exists on the opposite side of this triangle where we already have the hypotenuse in A. Opposite and hypotenuse are related by the trig function sine. So sine theta is equal to the opposite, which is AY, over A. So AY becomes the product of A being multiplied by sine theta. So that is 5 multiplied by the sine of 30, which we know to be 0.5. So AY is in fact 2.5 kilometers. So as you walk your 5 kilometers 30 degrees, say north of east, the vector AX, the component AX is 4.3 kilometers, and AY is 2.5 kilometers. Right? This is the beginning point that we've actually used in our intro to 1D vector, or intro to 2D vectors. It's just adding by Pythagorean theorem. However, we can treat this data a little differently. So let's expand this approach. Let's imagine that you walk a similar vector, maybe 3 kilometers, and you do that at, say, 35 degrees on a direction that we can call north of east. Well, from that point, maybe you turn a little bit more northward, and you go 4 kilometers. And we'll call that turn that you made more like 70 degrees north of east. Well, the method that you began on the previous slide actually allows you to add these two together to get the resultant vector, which would be like saying, what if I walked to where I finished in a straight line? So 3 ends up being component A, 4 ends up being component B, and this white line is your resultant. It's the addition of those two vectors, and more importantly, it's the component addition of those vectors. So here's how we proceed. We need first to determine what the components are. So we need to calculate components. And I like to just say AX, AY. Get them out of the way. So that would be 3 multiplied by the cosine of 35. AY is going to be 3 sine of 35. Well, we can, since we're going through this, we can say BX and BY as well. BX is going to be 4 cosine 70, and BY is 4 sine 70. So we've gone ahead and calculated what those components are. So if you take a look at the drawing, 3's x component is how far it went on the x-axis, and 3's y component is how far it went here on the y-axis. So that's AX, AY. And likewise, this is BX and BY. So now, if we add together those like components, we're going to get the two sides of this right triangle, what we are going to call RX and RY. So RX is going to be equal to AX plus BX. And that actually equals, if you take a look, 2.45 and 3.82. RY is going to be equal to AY plus BY. Which gives us 5.48. So we have these two sides of this right triangle, and forgive the unusual way that I'll solve this. I'm going to try to squeeze this a little bit. Try to do this for you. What we'd like to know is just how big is R. And once you get two sides of a right triangle, you know that it's Pythagorean theorem to solve for that third. So it's Rx Ry squared. So we end up with 3.82 squared plus 5.48 squared. And we take the square root of that, which equals 6.34. Now obviously we're ignoring significant figures here. If we weren't, we could say it's 6 kilometers. Now, sorry to do this to you, but the last thing that we need to do is kind of slide everything over here. We need to know this big angle right there. So basically, from the x-axis you started your trip on to your resultant, what is that grand angle? And we call that angle theta. Theta is based upon the opposite side of this right triangle that's formed right here over the adjacent. So we know that tangent theta is equal to Ry divided by Rx. That's the idea that opposite over adjacent. Opposite the angle, adjacent the angle. So to solve for theta, you actually need to take the inverse tangent of what Ry is, and that happens to be 5.48, and we divide that by 3.82, and you get theta equaling 55.1 degrees north of east. So the final answer, if you're reporting it, would be 6.34 kilometers at an angle of 55.1 north of east. So I'm asking for more than just the magnitude, but also the direction. Now I hope this helps. Obviously that this is intended to be sort of a review from what we did in class with maybe different numbers. Please feel free to see me, especially if you're still having trouble with some of the trig functions, and I will see you in class.